Hello everyone, my name is Luis Miras. Welcome to my talk, Other Wireless New Ways to be Pwned. This talk is going to have, we're going to have a live demo here. There's going to be some hardware hacking. We're going to be injecting signals into various wireless devices. And let's get started. So first I'm going to start out by saying what I'm not covering. Lots of other people have been looking at 802.11, other types of wireless stuff, and that's been done. I'm looking at something a little bit different. I'm not looking at Bluetooth, and I'm not looking at cell phone stuff. We're going to be this talk is going to be covering the other kind of wireless devices that we see very often. We're going to see RF wireless presenters, a couple different types. We're going to see wireless mice. Wireless mice, everyone's using them. There's some Bluetooth ones, but the majority of them are RF. And they're, as I'll show you later, there's no encryption. There's nothing going over the network to over the air to authenticate them. So it's replay attacks can happen. Injection attacks can happen. This is very rudimentary type stuff, and being able to get access to the point of injection and the point to sniff is not that difficult. So part of this talk isn't so much showing these vulnerabilities, but kind of giving a tutorial on how you would do these types of attacks yourself, and how you can take a look at some of these hardware devices, and with very little amounts of hardware skill, you'll be able to implement these types of attacks. What I'm trying to do is bridge the gap between, most of us do a lot of software, and we can attack things over the network, we can write buffer overflows, we can do run debuggers, all kinds of stuff like that, and we're very comfortable with it. And for some reason, a lot of people are scared of hardware, but it's really the same thing. It's about putting the signals you want in the right places, and about being able to read what's coming out of a device. Same thing as writing an exploit for something else. It's just a little bit different technique to get there. And we'll do a little bit of overview on wireless keyboards too, and the differences between the type of communication that happen between a wireless keyboard and wireless mice and a wireless presenter. So what's in common with all these devices? They're supposed to be low cost, but if you go to Fry's, you'll see a wireless mouse that uses RF, the same price as a Bluetooth one. The Bluetooth one has to pay licensing fees, has to pay for a chipset, so it's in the manufacturer's best interest that you buy the RF ones because they use very low quality chips. Most of the time it's one-way communication, and it's pennies on the dollar compared to Bluetooth chips. So there's no financial benefit for any of these manufacturers to create something secure. Even though there's been Bluetooth attacks, at least there's a base level of encryption and authentication. Whether that has been cracked or not, at least that's there. You're relying on something else rather than a proprietary protocol and algorithm, and security through obscurity, and hoping that no one's going to figure this out. All these are using what's called USB HID, which is human interface devices. When companies started making USB devices, particularly keyboards and mice, they didn't want to have someone have to install drivers over and over again. Oh, this doesn't work in Windows 95 when USB came out, or this doesn't work in Mac. They wanted it to come from a certain standard and be able to work across platform and across different operating systems. So they could develop the USB HID standard. This controls how these types of devices communicate and what type of functionality they can provide on your system. These are mostly using unlicensed bands, 27 megahertz, 900 megahertz. I've seen some at 49, 2.4 gigahertz. And even though it's 2.4 gigahertz, don't assume that that's going to be Bluetooth or Wi-Fi. It's still it's sped spectrum, but you can still access the chips and be able to read data off of them. There's no encryption and there's no authentication. There's claimed ranges of about 50 feet. Just like we've seen with Wi-Fi, you can put antennas on any of this, and you're going to increase your range. You're going to be able to attack from greater distances. And especially if it's a 2.4 gigahertz system, you already have a CAN antenna. You can use the same antenna to be able to get longer range, to be able to sniff some of these keyboards or mice or what have you, and be able to inject traffic from further distances. Part of the problem with this type of attack is that you have to be relatively close. If you use something, an antenna, maybe some kind of a preamp, you'll be able to get longer distances. So let's start looking at some of the HID stuff. So HID generally means it's the USB HID standard. You can do HID over different types of protocols. It doesn't have to be USB. If you look at the Windows directories for their for their HID drivers, they can do HID over, I believe, serial, and I know they can do it over IRDA for sure, so over infrared, and over Bluetooth. There's a separate standard for that, but all these devices will communicate the same way. And so what does this define? This defines the way that the devices talk to each other. There's going to be a single host and a device. They talk to each other. They can't talk to anyone else. And the goal here is to not use any drivers. So that means that the device has to hold a description of itself, because the host doesn't know anything. So the device is going to hold the HID descriptor, and these devices are going to have very limited processing power. Usually we're looking at 8-bit microcontrollers. So even if you attempted to do authentication, you're not going to be able to do any real type of hashing or encryption with an 8-bit processor running at maybe a couple megahertz and possibly 256 bytes of RAM, maybe about 32K of flash. So on these devices, the microcontrollers, the RAM is usually just primarily used for the stack. You're not going to have any type of allocation. They're all written in assembly. Some of them in C, but there's no operating system. So they're just writing straight to the device. So even if you wanted to do this type of encryption or authentication on top of the channels that are provided, it's not going to work. That's why we have Bluetooth chipsets that offload all the processing and authentication to those particular chips, because the devices controlling them don't have enough horsepower. So these devices, what are the most common types? Obviously, there's going to be keyboards and mice. That's what the 99% of the devices are going to be. Something interesting is that most of the devices are going to authenticate or are going to claim to be a keyboard. It doesn't have to be a keyboard. It's just the way it communicates and the type of commands it sends. The wireless presenters, all they're sending are page up, page down keyboard commands. So when you plug one of those in, it recognizes it as a keyboard. Mice don't send key codes. They send movement. It could be relative movement, like when you use a mouse and you just put it down and you start moving it. It doesn't really matter. Or you can also have positional movement. Let's say a CAD drawing table or one of the drawing tablets, where every specific location is an absolute location in relation to the screen. And of course, there's buttons on top of that. So I'm going to take a look at some of the less common HID devices, just to let you know what other types of devices will be able to send this type of data. So we have the Power Glove. The Power Glove is a HID device. So if someone was using the Power Glove for something else besides playing with their Nintendo, they decided that it would be like super cool to use that as a front end to IDA, so you can like click around. You don't want to touch the keyboard. You want to click buttons on your hand and be super cyber. So you'd be able to inject keystrokes, whatever keystrokes they send, be able to inject those to that person. And then there's everyone's favorite, was the Wii controller, which also identifies itself as a HID device. Same type of thing here, except this device uses Bluetooth. So it does have an authentication layer on top of it. The other devices do not. But they all fall in the same category. Here's another HID device, Dance Dance Revolution. You could be playing Dance Dance Revolution against your friend and start injecting the wrong buttons, and they're going to lose. And they're going to lose, and you're going to look like this. So let's take some of these devices apart and see what's inside. Here's a wireless presenter. You're going to see basic patterns between all these devices. They're going to have kind of the same types of chips. Not the same chip, but the same type. We see here that we're going to have a transmitter chip, which is the one, the leftmost one that's circled there. And there's also a couple other chips. The bottom chip is the microcontroller, 8-bit microcontroller, like most of these devices. And we're going to see a serial EEPROM. So what's going on here? There's obviously the microcontroller is taking care of business. It's the one that sets up the protocol, talks to the transmitter chip. It's going to prep everything up and send it out. There's a serial EEPROM. That must hold authentication data. Even if it's just one-way traffic, it'll be maybe a serial number or maybe some kind of shared key that does not get hashed, because when we look at this chipset later, it's only one way. It's not a transceiver. It's only transmit only. So anytime you're transmitting only, if I'm talking across the room and I can't hear back, there's no questions, anyone can repeat what I'm saying. So there's right off the bat, we have replay attacks. Here's the corresponding dongle for that same presenter. And what we're going to see here is there's going to be a microcontroller as well that's going to double as the USB chip. So whatever data it gets and it decides that it's valid for that device, it's going to package it up in the USB packets and send it through your port, up through the host chipset, through the stack, back up to your computer. And here, again, we see the serial EEPROM. So this is the same authentication data. If you want to compare it to, let's say, like Bluetooth, these devices are paired at factory and cannot be repaired. And here's the receiver chip for the device. That's going to operate on the same band, and it's receive only. So once again, one-way traffic. Here's a Microsoft mouse. The microcontroller is going to be very close to the circuitry that takes care of the laser, that reads the laser. Then there's going to be, once again, a transmit chip and a serial EEPROM. And this is the dongle for this mouse. And we see a receiver chip. And there's a USB controller and the serial EEPROM that holds a 128-bit value maximum, which means